Unit 6, this is 6b. So we're doing simplifying, multiplying, and dividing rational expressions. So first thing we're going to do is simplify. So to simplify a rational is just dividing two expressions. So we have simplify. What you do is you're going to see if you can factor each numerator and denominator first. So factor the numerator and denominator. The numerator is just a monomial. There's nothing to factor there, or you don't need to factor it. The denominator, so you factor it by first taking the greatest common factor out. So the greatest common factor between these two is 6. So you have 6, and then there's an a. Don't forget about the variable. So divide the first term by 6a, you get 2a. Second term divided by 6a is 7. Now we want to state the excluded values. Actually, let's simplify here first. Numerator and denominator. Now it's all factored. You do 42 divided by 6. You can divide them both by 7, so it's, or 6, you get 7 over 1. There's an a as a factor in the numerator and a as a factor in the denominator, so those cancel out. And now let's rewrite what we have. In the numerator is just a 7. We have 1 times 2a plus 7 is just 2a plus 7. In order to simplify, you have to have factors. So the factor 2a plus 7. So you need a 2a plus 7 in the numerator to simplify, cancel this out. You can't cancel these 7s. We also have to state the excluded values of what a, not x, a, of what a cannot equal. So you look at what was variable-wise, let's cancel the numerator and denominator. So we look at what we've, numerator and denominator variable-wise that we've canceled out, simplified out, and those are the a's in this case. And you look at that factor, what makes that factor equal to 0? And the thing that makes a equal to 0 is, it's kind of a trick question, it's 0. So in order for the simplified rational to be equivalent to the original, we also have to say that a cannot equal 1, because in the original, if you put, or a cannot equal 0, if you put 0 into the denominator in the original, you would divide by 0. Let's move on to example 2. So example 2, we're simplifying again. It's just one big rational expression. So again, first thing is to factor the numerator totally. There's no greatest common factor. It should always be the first thing you think about. No greatest common factor. The leading coefficient here is 1. The a in this quadratic is 1. So there's a shortcut to factor. What two numbers multiply to 60 that add up to 16? And so we have 10 and 6, you should be thinking. So x plus 10, x plus 6. In the denominator, the greatest common factor there is 3. Because we have more than one step here, I'm going to factor out a 3. On the inside here, now we have a in this quadratic is 1, so again there's a shortcut. What two numbers multiply to negative 10? That'll add up to 9, and that's positive 10 and negative 1. So now we have, now we're looking at, oh, don't forget the 3. So looking at this now, what in the numerator and denominator, factor-wise, can we simplify? And it'd be greatest common factor, if there was one, that it could simplify. But it's just x plus 10s. So let's rewrite what we have here. On the numerator we have x plus 6. You don't need it in parentheses, because you're not multiplying it by anything. In the denominator, you have 3 times x minus 1. If you want to multiply it in, you can. Leave it out, that's fine. And then we say our excluded values. What factors did we cancel out here that have a variable in them? And the only one is the x plus 10. So what will make that factor 0? By putting x equals negative 10 in it'll make that factor 0. So in order for your simplified version to be equivalent to the original, you have to state the excluded values. Moving on, multiplying and dividing. We're going to have one example of each. Multiplying is very, very similar to what we just did with simplifying before, except now we have two fractions. So it's just twice as much factoring, but still it's all just factoring. So we have 5n squared, nothing to factor there. So 5n squared. The denominator, greatest common factor, you should be saying 5n squared. And if you divide each by 5n squared, you have n plus 7 times, and then n plus 7, you can't factor it any further. It's not a binomial, there's no greatest common factor. Or it's not a quadratic, I should say. Alright, the next numerator, 49 minus 21n, you can factor out a 7. And you're left with 7 minus 3n. In the denominator here, there's no greatest common factor, and the leading coefficient, the a is not 1, so we do 3 times 7, so this is how to factor it. Not all of you probably factor this way, but this is a surefire way to always get it rather than guessing checking. So I did a times c, 21. What two numbers multiply to 21? That'll add up to negative 10, and that's negative 3 and negative 7. So in the Punnett square, great square, you put top left, put the first term, bottom right, last term, put the two terms that you just found with the middle variable, n, middle term's variable, the b's variable. And now take out your greatest common factor of each column or each row. And each column here, 7. And when you multiply them back out, 3n times n with a Punnett squared, they have to all match up. So n times 7 is not negative 7n. So what you end up going to do is you're going to put negatives on the 7, and 1 times 3n is not negative 3n, so but it has to be. So you put it on, always put it on the second term. And you still have negative 1 times negative 7 is still positive 7. So there's our factors of 3n minus 7 and n minus 1. Okay, let's look at what we got here, numerators and denominators now. Since we have multiplication in the middle, we can simplify by, it's kind of like cross-simplifying. So, looks like we have n plus 7, no n plus 7. We have 5 as a factor, divided by 5, that's 1, and so 1 over 1. And n squared over n squared, that's 1 over 1. 3n minus 7, 7 minus 3n. Those are very, very similar to each other, but they're not exactly the same. So what you're going to end up having to do... Alright, so we have 3n here. So I'm looking at these two terms. 3n is positive, here 3n is negative. Here 7 is negative, here is positive. These happen to be opposites. So you can actually do more to these two terms, these two factors, to create them to be equal. If they're opposites, you can factor out a number. So what you're going to do is we're going to factor in, it doesn't matter which one you work on. I'm going to factor a negative 1 out, which gives you negative 7 plus 3n. And I'm going to rewrite this. So that's what we're replacing this with. So over here we have 1 times 1, 1 over 1 times 1 times n plus 7. Then we have 7 times negative 1. And then we have negative 1 times 7 is negative 7. Over factor of 3n minus 7 times n minus 1. So now, if you want to rewrite this so the n term is first, you can. But these two here are the exact same. You could use the commutative property of addition if you'd like to switch them, but no need. And then I look at any numerators and denominators that are same, nothing. So let's just multiply across the numerator. Once you have everything simplified, multiply across the denominator, n plus 7 times n minus 1. And now we have to state the excluded values. So we go back to the beginning, any of the denominators that we simplified, the factors. So here we have n squared. What will make n squared 0? And that would be 0. So n cannot equal 0. And then another factor in the denominator that we cancel out with the variable is 3n minus 7. 3n minus 7, if you can't figure out what number makes that 0, make it equal to 0 and solve it. You'll get 7 over 3. So those are your excluded values. N cannot equal 0 and 7 over 3. Alright, let's look at the last problem. I know it's getting extended time, but alright, last problem with division. The only thing that's different with division is we have to change it to multiplication. So we keep the first fraction the way it is. So keep it, change that division sign to a multiplication. And in order to do that, mathematically, you have to switch, you have to do the reciprocal on the second fraction. So you switch it, switch the numerator and denominator. Over 10x squared plus 7x plus 1. The next step is the factor. So the next slide you see, it'll be factor. Okay, so I factored each numerator and denominator. Now I just look at numerators and denominators that I can simplify out. 5x plus 1 divided by 5x plus 1 is 1. You can put 1s here. I have a tendency to put 1s. 3x plus 4 over 3x plus 4. That's the same thing, they're 1 over 1. 2x plus 1 over 2x plus 1. And that is it for factors. So we have 1 times 1 times 1 times x plus 2. It's just x plus 2 over 4 times 1 times 1 is 4. And then we state the excluded values. X cannot equal. Look at your denominators. What will make each denominator factor equal to 0? So this would be negative 4/3. Here would be negative 1 over 5. And this one would be negative 1 over 2. And those are excluded values. So that's equivalent to the original if and only if x cannot equal negative 4/3, negative 1/5, and negative 1/2. From the classical questions. Thanks.